Hello everyone. I wanted to show you a tool I've been building which I call MatCalib Pro. It does one job. It takes your material test data and turns it into a ready to run LS material card. So if you have ever sat there converting engineering stresses to true stresses by hand, hunting for the right yield point, and then lining up the keywords fields one column at a time, this tool is meant to take that whole chore off your plate. This tool is free for now. It runs locally on your own machine, your laptop, your desktop, and I'm putting it out to get your honest feedback from you and from people who actually run these simulations. So please stick around to the end because what you tell me decides what I'll build next. Um, so let me start with the problem because you've all lived it. So going from a stress strain test to a working card has four tedious, error-prone steps. You convert the engineering to true stress, and it's easy to slip past the nicking limits or fumble the formula. So then you pull out the modulus and the yield point, and a noisy digitized curve will happily fool a naive slothfit. You build the hardening curve in the exact form the card wants with its own field layout. And actually, the quiet killer, which is that you need to keep your units consistent. And this is very, it's very, you have to be very careful here because, for example, a density in the wrong unit if a dynasty has a wrong unit, it will be just not just wrong, it will be wrong by 12 orders of magnitude. And there is nothing to warn you about it. So MatCalib Pro will handle all four steps, and it's actually built, to be honest, when the data cannot support an answer. So I will show you here on the presentation slides. Then I will move to the tool itself to show you like a quick example how we can use it. So here we have in this slide, this screenshot tells everything. We have uh, 5 steps in the software. The first step, which is the material, or to choose the material you want to work with. We have a lot of material families here. We have metal, we have polymer, we have rubber, we have composite materials, we have foam, we have shape member alloys, ceramics, biomaterial, and we also have piezoelectric material. So you choose the material you want to work with, the material family, and also you can choose the unit system you want to start with. Then in the second step, after you press continue here, in the second step, the software will take you to the test data. It will ask you to drop your files here, the data you have. These data could be in the form of CSV file, Excel file, or plot images file, or mix between all of these. And you choose the type of test these data represent, tensile, is it compressive, or is it shear, and the strain rate if it's specified. The default is quasi-static strain rate. If you have something else, you can just write it down. Then you press to add the curves. Then you press or you click on the continue button. Here you specify exact card you want to get out. If you choose metals in the beginning, you get to choose between 3 cards, 24, the famous 24 card, 15, or the 18. Then you press on the calibration button, then you press on continue. It will ask you which kind of files you want to export, all of that. We have here the .k file for the LS-DYNA solver. We have the PDF report, which will give you a report, detailed report about the material properties you have for the material card, and an Excel summary that summarizes everything you've done. I will now move to the tool itself to show you a quick example on how to use it. So it's very easy and very straightforward, as you can see. So here we have the material, the software itself. We have here the material step. So we have several unit systems. So I will go just with the first one, and we have all of the material families. I will just click on metal for now, and you can initially go with specific material card. So let's go with MAT24. Press on continue. The second step is to add your test data. So let's go. I will go with the worst material card. Sorry, the worst material data ever, which is a plot image. Okay, so let's go for the plot image. Yeah, so it tells me it needs manual calibration. Okay, so I will just press on calibrate. So I scroll down here. It asks me to add 0.2 points on the x-axis, the minimum and the maximum. Then the same thing for the y-axis, the minimum and the maximum. And then here to enter the minimum value for the x-axis, the maximum value, the same for y. I will go with a megapascal, so it would be 875, and press extract. If you have multiple curves, more than one curve, you can use this option here. All right, this is like a brush that you can go through the curve you would like to extract the data from, or you can choose this option here, which it's not a brush. It would be like a point by point. It will take a bit of time. So the brush is, I think it would be the easier one. But anyway, two options are useful. So I'll press on extract the result. So now I want this to be the tensile test. If you have another data, you can just drop them here the same way. If you have a CSV file, it would be much easier. You don't have to calibrate it or anything. It would be easier than the plot image. So after finishing all of that, you can just press on that one, add all tagged curves. All right, now it's added, and it's telling you you have like a medium confidence in these data that been extracted. So I press continue. Now, let's say so the value of the modulus or the Poisson's ratio. You know the value of yielding point. You can just add it to increase the confidence. If you don't know, that's okay. That's fine. Let me add the density for the material. Let's say 7.8 minus 9. And check unit consistency. Actually, if I pressed on continue, pressed on continue and run the calibration, it says there is one parameter that it cannot run. So when I press here, run calibration, it takes me a step back and tells me you've entered the wrong unit uh, for one parameter that's not consistent with the unit system you choose in the beginning, which is the density. Of course, I knew that. I just wanted to show you because we choose ton. So we need to ton per cubic millimeter. So it converted the value I entered, as you can see, from -9 to -18. So let's make it correct, right? It's not -18, that's correct. But it's just converted it mathematically. So we're now okay. You can actually press this button here, check the consistency. It's telling me everything is good. So we press continue. And again, we want to use the material 24 for now, run calibration. And as you can see, we have the value extracted. So when you press continue, which files would you like to generate? This or this or this or all of them? Let's generate all of that. Writing and generated. And when you open the folder, so this is the report, the PDF report, right? And this is the Excel summary, just a small summary. And this is the .k file, as you can see. Or we can open it in LSP post. So this is LSP post. Let's open the keyword manager. We have here, as you can see, the material card. Let's open it. Okay, we have here the material card, we have the density, the Young's modulus, Poisson's ratio, the yield point. We don't have the effective plastic strain or the corresponding yield stress because they are all here in the plot. So we can plot them like that, as you can see, or you can just go to the curve that being generated here and read. As you can see, here is all the data, and we can plot the same thing. So we don't have much to do here because everything has been handled based on the data that has been entered to the software. So this is it. I would like to ask you to just try it and let me know what's missing. Drop your thoughts in the comments. Every reply genuinely shapes what gets built next. I will read all of them, and um, thanks for watching, and give it a try and let me know how it goes. Thank you.